My name is Greg Theron, and I'm one of the product managers at FeatureBase. Previously, I spent 7 years as a data engineer, 5 of which were working on ML model and pipeline implementation. So today, I want to talk a little bit about bitmaps, which is probably something you've heard of, but haven't knowingly used that often. I'll give a high-level overview of what they are and why you should be excited about them going forward. And lastly, I'll have a shameless plug as we do at these things and go over a use case that highlights exactly what they can do. So to start, no, we're not talking about bitmap images. We're talking about these kinds of bitmaps. So a bitmap is, lo and behold, a mapping from some entity down to bits. Said another way, a bitmap is a series of binary values that describe whether a relationship between two entities does or does not exist. So let's consider a Boolean column in a customer table that indicates if they are a premium customer or not. A bitmap would be the binary mapping indicating who is premium across all these customers. So you can kind of see highlighted in red here, right? This is what an actual bitmap is. Note, this is the transposed view of a traditional table in order to better visualize what a bitmap is. And it's easy to visualize a bitmap as an array of binary values, which is also why bitmaps are referred to as bit arrays. So why do we want to store things as bitmaps? From a really high level, bitmaps are computers' natural language, usually called machine code. Bitmaps, in theory, should be able to be read in by CPUs with less overhead than other formats. Bitmaps also lead to a large reduction in disk footprint because only a single bit is needed to store the mapping to that value as opposed to the entire value each time. And this is best represented with another example. So let's take a traditional table of animals and have a bunch of attributes about those animals. Here we need to store categorical fields such as primary movement that tracks how an animal primarily moves. And again, let's look at this table as a transposed version. So a bitmap index is a type of database index that is made up of bitmaps. It's easiest to imagine this as a large matrix filled with just ones and zeros. This is called a bitmap index because each bitmap is essentially a pointer to a certain value in a column. So for this example, we have the primary movement column. Previously, each movement type was stored every single time. But with bitmap indexing, those values are only stored once, with each animal only requiring a single bit set to indicate its movement type. So again, we don't have to store the value, let's say swimming, over and over again for every animal and fish and that primarily swims. We just have to set it once and set a single bit each time. This type of efficiency can be achieved in creative ways across other data types like numeric and datetime using what's known as bit slice indexing, but we're not really going to cover that today. The bigger message is across a large number of records, bitmaps naturally result in massive storage savings. These storage savings also translate to compute performance. So bitmaps make computations on top of the data much more efficient by creating Boolean relationships. So Boolean and or not logic and aggregate count and sum operations are really performant on bitmaps. The reduced data footprint also means more data can be stored and computed on in memory using the exact same infrastructure, enabling you to scale without having to scale. So hey, saying the title during the presentation, killing it. So why isn't everything stored as this new bitmap thing? Well, first off, these aren't new. Bitmap indexes started showing up in databases a while back, around 1985. They're generally found to only work with low cardinality columns because bitmaps offered space savings compared to row identifiers in traditional B trees. But high cardinality columns couldn't really do this. They would result in higher storage and also led to much higher scan costs than B tree indexes. So bitmaps also pose different challenges when it came to data manipulation and some of the feature engineering that we're used to today. But even so, they're used in applications today that you're likely familiar with, such as Postgres, Oracle, DB2, and FeatureBase. A lot of time has gone into improving bitmaps over the years with sophisticated encoding techniques that allow improved compression on bitmaps in addition to computation on top of the compressed bitmaps. And a big shout out to the Roaring team over the past years for a lot of those advancements. Additionally, technological advancements in general over the past 35 years has been vast. So this leads me to brace my shameless plug for FeatureBase. We are the first database to operate entirely on bitmaps. Our mission is to leverage the performance, efficiency, and simplicity of bitmaps as a foundation for real-time analytical data technologies. And I'm not going to go list a large amount of features and marketing to convince you of that, but would rather want to jump straight into what one of our customers, Tremor Video, was able to achieve. So Tremor Video is a global leader in video and connected TV advertising. They collect data from over 6 billion devices like TVs, phones, tablets across 40 million households, and need to process and act on that data in real time to create accurate customer segments for highly targeted advertising. These campaigns run across devices, which can be in multiple segments at any point in time, with segments containing anywhere from hundreds of thousands to even a billion viewers. Prior to FeatureBase, Tremor Video was forced to use sampling methods in addition to over 1,000 Hadoop servers just to batch and pre-aggregate their data for segmentation and targeting. So even with these steps, the process took anywhere from 24 to 72 hours before a person could be targeted with an ad, which is a really long turnaround time. But honestly, it's something I see, hear, and have even experienced quite often in the industry. So what did Tremor need? Creating segments in real time means Tremor needed to send 500,000 to 1 million records per second to Kafka that are associating segments back to devices. This not only needs to handle inserts for new devices, but also update existing devices with new segments. Additionally, the solution needed to be able to give sub-second to second response times for queries for over 1,000 concurrent queries. Bitmaps were the only format Tremor found that could meet these requirements because of their space and computational efficiencies. FeatureBase handled this by having each device represent a key, the key entity in a table, and handling over 1 million upserts per second. FeatureBase is then able to constantly update the 0 to n segments for each device using update transactions and even deletions with time to live functionality. Not previously discussed, but only having to set or unset single bits to track changes leads to a big hand in why even update transactions can be handled with bitmaps at such a large scale without impacting latency. While this heavy ingest is occurring, users are still able to query these segments in order to execute and report on advertising campaigns. Additionally, consuming these segments is now all done without requiring any pre-aggregation of the data at all, and is accomplished using only 11 servers instead of the 1,000 plus, with a 92% reduction in memory. And by the way, no pre-aggregation here means this operates on over 16 terabytes of data with around 120 billion new events every single day. So I'd love to jump into this use case a little bit more to discuss the data model and what it took to complete, but 10 minutes is a pretty short time. So more importantly, I hope you take away that bitmaps are an extremely powerful format that you should consider more often in the future for analytics. And if you don't want to take my word for it, I'm really happy to announce that as of September 7th, FeatureBase is officially open source. So go give it a go yourself at FeatureBase DB on GitHub. And while we covered an analytics use case today, I'm sure most of you in this audience can see how these bitmap matrices can be a perfect match when it comes to ML models and feature engineering. So certainly consider leveraging bitmaps for those use cases in the future as well. Please reach out to me in the FeatureBase community on Discord or over email with any questions you have. Otherwise, have a good rest of the conference, and I hope to share more with you on bitmaps in the future.